In this video, we are going to see game playing with an example. So let us consider a problem in game playing. This is a state space tree and all the utility values are available in the child node. So their algorithms are used for solving the game. One is min-max algorithm and the second one is alpha beta pruning. First we are going to see min-max algorithm. So we can start with the leaf node. We need to name the player. There are two players, max player and the min player. The first level is for max and the second level is for min. Similarly, alternatively, we have max player. Now the max player has to make the decision. So maximum player has to choose the maximum value and min player will always choose the minimum value. So here when you consider 5 and 7, 7 is the maximum value, so it is selected. Similarly in the next node 10 and 3, 10 is the maximum value. Similarly in next node 2 is the maximum value. So this will be repeated for all the values, all the child values, and the maximum value is selected in the third level. So next come the min player. Min player will choose a minimum value. So here 7 and 10, so 7 is a minimum value. Similarly in the second node 2 is the minimum value and finally 8 is the minimum value. And again this is a turn for the max player. Max player will always choose a maximum value, therefore 8 is the maximum value. So therefore this max player will choose the path or the child branch which is having 8. Here the branching factor is number of branches is 21. So the levels are 4. So it requires 21 power 4 searching. Next comes to alpha beta pruning. So in alpha beta pruning, this is an optimization for min-max algorithm. Here we can reduce the number of branches. So the branch which is not leading to a promising results, that branches are pruned. Here we have an initialization condition. Here we are using two terms, alpha as well as beta. Alpha is for max player and beta is for min player. So the objective of max player is to maximize the value. So and in the initial value we are assigning the least value, that is minus infinity, and for beta we are assigning the maximum value. This objective is to reduce the infinity. So this is the initialization condition. The next is the pruning condition, when we have to stop or we need to cut the branches. Here when alpha is equal to or alpha is greater than equal to beta, if this condition is met, we need to stop the searching in that particular subtree. So this is a pruning condition, and we have to assign the max player, min player as well as max player. This is an alternative. We need to assign in alternative way. And we have to give the initial values, alpha it is equal to minus infinity and beta is equal to infinity in the first root level, and we have to start the searching in left hand side. Therefore this value is passed to the leftmost child, and again the same value is passed in the leftmost child. So here max player is having this value of max player is changed here because this is the choice of max player, and it looks the first left child, it is 5. Therefore the 5 is greater than minus infinity, so it is erased and the 5 is replaced there. Similarly it checks the next one, 7 here, and this 5 is replaced and 7 is placed here. So therefore this value is reflected in the min player, because in min player beta value alone changed, alpha will not be changed. So here when we consider the value of this node is 7, so that value is taken here, beta, and the same value is passed in the rightmost tree. Alpha is equal to minus infinity and beta is equal to 7. And here max value alpha has to be changed. So it considers the value of 10. The leftmost child is 10. So that will be replaced here. And they'll check the next value. This is 3, which is not greater than 10. Therefore, they'll retain this 10. Sorry, here the pruning condition met because alpha is greater than beta. So therefore, we have to stop the or cut the branch. And this 10 will be retained here. And this value is passed over. So here beta has to take the decision. There are two values, 7 as well as 10. Already 7 is there. So 10 is greater than 7. Therefore, it takes a minimum value 7 alone. So this value is again passed to the root node. So here max player has to change the value. Alpha is equal to minus infinity, that is replaced by 7. So this value will be given to the next child node. Alpha is equal to 7 and beta is equal to infinity. So the same value is again passed to the left child. And here max player has to take the decision. Here the first value is 1, which is less than 7, so therefore it is not changed. Similarly here 2, that is also less than 7, so therefore alpha retains the same value 7 here. And when you take the min value, beta has to change the value. So here 7 is there, so the beta is infinity is changed as 7. And here you can see the pruning condition meets. Alpha is equal to beta. So therefore we need to prune the branches. Okay, and hence this 7 is retained here. And again the first level alpha has to take the decision. Already 7 is there, and here also we got the same value, so this value is retained here. And this is passed to the rightmost tree. Alpha is equal to 7 and beta is equal to infinity. And it is again passed to the leftmost child. Here alpha is equal to 7, beta is equal to infinity. And here the leftmost child is 8. And this is a turn of max player. So the value of 7 is replaced by 8. And when you consider the next level, it is 2, which is less than 8. So therefore it is not replaced. So we can keep 8 in this subtree. And this value is reflected here. Therefore the min player is changed its infinity value to 8 because it is less than infinity. And alpha is equal to 7, beta is equal to 8. The value will be passed over here, the right node. And here alpha has to take the decision. Here alpha is equal to 7 and the left child node is 9, which is greater. Therefore 7 is replaced by 9. So when you see here, alpha is greater than beta, pruning condition meets. So therefore we have to stop the process and we need to keep 9 here. Okay. And when you take these two in the min player, here again 8 is there and here 9 is there, which is greater. Therefore we can keep the same value, min value. And here when you take the max value, so the max player is already having 7, in alpha is having 7, and again we have 8 is there, so therefore the 7 is replaced by 8, and that is present or that will be kept in the max player, and he will take this path for further travel.